Yep. Cool. Again, welcome to the third day of the workshop. Today we'll be covering a few important technologies. So we'll be looking at how we'll structure our project as and when it progresses. We'll be looking at how we can talk to a server, what are the other methods we can talk to a server, and what are the purposes of having these methods. We will be looking at how you can document your APIs and why the purpose behind documenting your APIs, right? We will be looking at a few types of databases. We will be starting to work with databases in our APIs. So we have a lot to cover. So please stay in the pace. Cool. So the first thing that I want you all to do is go to the repository that you cloned yesterday, right? After you joined your GitHub Classroom, you would have a repository. Just clone it, and if you haven't cloned it, clone it now. And if you've already cloned it, we did some code yesterday. We developed our first web server, didn't we?
Yes.
Okay. So I want you to delete all the files from that folder. Just completely remove all the files from the folder that we created yesterday from the repository. Just tell me when you're done. And for the ones who haven't cloned the repository, please do it as and when we do it. I just want you to clear out the code that we wrote yesterday, including the node modules. Just make your repository empty. Yep, even don't delete the GitHub folder. I don't want you to delete the GitHub folder. It has .github. Don't delete that. Just delete all the other folders that we created. To make things easier for you, you can just head over to the source control tab. You'll find changes. Just click on revert, this button which says discard changes. When you click on that, it basically gets back the repository back to the original stage where it was. So I want you all to do that if you haven't deleted it.
We can actually see only your camera.
Okay. Cool. Head over to the repository. You will find all the files that we created yesterday. I want you all to remove that and keep it clean. Keep your repositories clean. We're gonna start from scratch. I'm gonna give you another 20 seconds. Okay, so I'm gonna begin again. So what did we do yesterday? We started a package. We created our first web server. What was the first step that we did? What did we do to create an npm package? Can somebody help me out? Okay, never mind.
npm init?
Yes, perfect. npm init. It asks for a package name. I'm gonna call my app the first API, and let's give it the default version 1.0. I'm not gonna give a description. I say index.js is my entry point, and there's not gonna be a test command. I just go proceed with the other default settings, and it asks if the basic package.json file is okay. I'm gonna say yes. So we have a package.json file. So we need to have a file which will be the entry point of our API. So we create index.js, right? Cool. After creating your index.js, what did we do? We are going to build a web server. What do you need to build a web server? In our case, we saw a particular module. We saw a particular framework that helped us in this regard. Can anybody get me the name?
Express.
Perfect. How do you import Express? How do you install Express in your project?
npm install it.
Perfect. npm install Express, right? But here's a catch. Okay, it's not gonna come now. I'll talk about it later. So we install Express. Cool. Right? So we did this. What's the next step? Can somebody help me with the next step? What do we do in our file? What do we do in the file, index.js? What's the first thing that we do in any file?
Import the Express module.
We import the Express module. How do you do that? You do that by importing the module into a variable, right? I'm gonna call it Express. I'm gonna require Express. Done, right? Cool. How do you create a server? We imported Express, and what's the next thing to do? You create a server. How do you do that? Come on, be quick. We don't have all day because there's a very huge stuff coming up for today's sessions. Please don't wait for the others. If you know the answer, just get right onto it.
Const server is equal to
Perfect. Const server equals you initialize the Express app, right? So this is how you initialize an Express app. So to define what this app is gonna do, what do you do? So you have a server, and you want the server to accept GET requests and respond back with a response. So what do you do here? How do you define? Does anybody remember?
Get request and response.
Perfect. Server.get. So this server.get method will listen to all GET requests coming under the first parameter. What would this first parameter be? // So this is basically the base URL, right? Do you all remember? And the second parameter would be a tuple, a function that handles the request and sends back a response, right? How do you do that? You define a request, you define a response, you define an arrow function. We did this yesterday. Okay? So what's the next step? It's right on my screen, right? You listen to the GET request on this endpoint, and you respond back with hello world. That's what we did yesterday. So you send back a message. So whenever somebody comes to the base URL on the GET request, we send back this message. We define what this route is going to do, right? So in order to make our server start listening, so far we've defined what this app does. So it basically gets a GET request and sends back a response saying hello world within the h1 tags, right? So how do you make your server start listening to actual requests? Does anybody remember? What's the method? It's very simple.
Server.listen.
Perfect. Server.listen. So now your server is gonna start listening to requests. And what's the first parameter? We talked about ports, right? Our first parameter would be the port where our app is gonna be running, and this in our case will be our web server, and we want our web server, our backend web server, to be running at 5000, right? Cool. So after initializing it at port number 5000, what do you want to do? You define a the second parameter which gets triggered whenever your server starts listening, right? Over here, I might say my server has started, or I may say my server is running at this so and so port. Go and look at the output, right? This is what usually any app would do. It needs to show some output for people to know that something is happening, right? So we log the output saying that our server started at port 5000. This is what we did yesterday. Okay. So far, do you all have any doubts? This is basically our web server. This is the fundamentals of building a web server. So do you have any doubts?
No.
No doubts. Perfect. Okay. So you successfully built a web server. How do you start it? What's the command to start?
Node index.js.
Node index.js. Stop. I didn't save the file. Yep. So when I do node index.js, the server has started on port 5000. How do I look at the output? I go to my browser. I need a client to talk to the server, right? Initially I told you your browser is basically a client which can talk to any server, and whenever we put in the URL of a particular server, our browser creates a GET request on behalf of the user. So let's say I'm gonna request HTTP. I'm gonna add I'm gonna do localhost at 5000, and cool, we have the output. Our web server is able to serve a content, right? So far, did you have any trouble in doing this? Anybody? Nobody? Okay. Okay, the other thing that we talked about yesterday, what was the important thing that we need to do here? So let's say I make some more changes. So I'll start the server again, and I'm gonna say server dot get, and this time it's gonna be another endpoint. It's gonna be workshop, and I do the same. I take in a request object. I send back a response. Alright, so this is what we did yesterday. But when I go to my browser, what will happen? Can somebody remind me what happens when I go to /workshop, the route workshop? We cannot get workshop. Why is that?
Server has not been updated.
The server has not been updated. Cool. So let's try doing that. We'll go to workshop. Yeah, there's no workshop because the server has not been updated. For your server to listen to changes in your file, what do? What did we use yesterday?
Nodemod.
Nodemod. And what is Nodemod? Can somebody remind the other people out there?
It restarts the server when a change happens.
Okay, so your Nodemod is basically a daemon. Okay, a daemon is any process that keeps running behind the screen, right? So a node Nodemod basically starts listening to changes in this file wherever you point it to, and basically it restarts the server automatically without you having to restart the server again and again. So to do that, how would you begin with? How do you install Nodemod? And here comes the catch. Somebody, yeah.
npm install Nodemod.
npm install Nodemod. But there's one important thing that you must know. Okay, this Nodemod actively listens for file changes by the developer, right? But when you deploy it on the cloud, you don't need this Nodemod process to be running, because you're not gonna keep making changes once you deploy, right? You won't use Nodemod in production. So that's what I'm trying to say here. So to save any dependency, so Nodemod is basically a dependency to our project. We saw what dependencies are, and we saw how we can install any dependency using npm install. So again, Nodemod is a dependency, but like I told, you cannot use Nodemod in production. You can use, but people don't use it. There are other production grade tools that you can use to deploy, right? So to do this, there's another flag that you say save, that says save -dev. What this does is it saves this dependency as a developer dependency, development dependency, dev dependencies. So let's look at what happens when I do this. Okay, so if I install a new package, I head over to package.json and I can find the dependencies. If you notice, we have a new thing, a new attribute that says dev dependencies. This is what I was talking about you have this Nodemod. This is a dependency which doesn't really install on production. So you need not use all of these dependencies. People usually install all the dependencies without even considering the development and the production, right? But whenever you install any dependencies that you would normally use only to develop and not to deploy, you would use this -save -dev. So this flag basically puts it on dev dependencies. Okay, y'all got that? I want somebody to unmute and say yes. So that, cool.
Yes.
The other thing that you must notice is this. You have a source control on the left. And I told you this is why you look at all the Git changes, the version control system, right? But if you head over to this version control system, you have all thousands of files, you know, these node modules. And here comes the problem. So in any project, you have all these dependencies that you didn't build. So basically all this code exists somewhere on the internet. You need not track changes in these files, right? Why would you need to track changes to a file, to a module that somebody else built, and he already has a version control system for that module, and you don't need that, and that's not even relevant to a project, right? So people normally, they don't watch for changes in these node modules. We don't need that. We need not take this node modules whenever we have to move or migrate our project, right? So to ignore node modules, we need, because the other reason is when you look at this node modules file, it has hundreds, and like it's more than, it's a very a black hole. It's like a black hole. So nobody wants node modules on their project to be tracked. And this is what we're going to do. We're going to create a new file that says git ignore, right? You do git ignore and you say node modules inside the file, and you save it. The moment you create a new file that says git ignore and you declare a file name or a folder name inside that file, git ignore, Git knows that it shouldn't be listening to changes on that file. It shouldn't be watching changes in that file, right? Did you notice when I refreshed the source control panel, the changes from the node modules were eliminated, were taken off? Did you all notice?
Yes, sir.
Perfect. So this is what you're going to do. You're going to create a git ignore file, you're going to put node modules in that, and you're going to do that, right? Quickly get me a yes if you've done so far. We have 7, 8, 11. I'm gonna start at 20. Okay, let's talk about another problem that you might face when you build the backend. Okay, yesterday, I don't know if many were there, I think Kritika was there. Okay, so she had a problem, and that problem was this. She started the server first and it worked, and the other time when she again attempted to start the server, it didn't allow her to start the server. This is because the port 5000 can only be occupied by a single process at any moment, right? At any instance. So Kritika already started a server, and the server potentially crashed, and it didn't it didn't clear out the port before dying. So it's like holding the port but not using it. You shouldn't do that, right? Any process, whenever you close the server, whenever you kill that process, should close. Or whenever you kill, whenever a server exits, you need the process to be killed. To do that, you have to do a change in your server's main entry point. So this is how you do it. You have a variable called process. This is not a variable. This is basically an object. Okay. Process is a special built-in variable which has event handlers. So there are event handlers that we are not going to get into. but I'll explain after writing the code. Okay, you have process on. So I'll just quickly explain what's happening here. SIGINT, SIGINT, this event is basically you typing in Control-C, right? So whenever somebody attempts to close an existing server, you want that process to exit, right? You wouldn't want that server to be running on a deadlock, and this is totally not acceptable by any development standards, right? So you do this on your file. So whenever somebody attempts to close it, it can exit peacefully without having to hold the ports or doing any mess to your project. To even identify what's happening, you can probably console log a message. So you say, I'm shutting down. So whenever somebody presses Ctrl+C, you forcefully shut it down and exit the process. So you can even have a look at what's happening here. So let's say I do Nodemod npx Nodemod index.js. So the server has started, and it keeps actively listening to my changes. And when I click on Ctrl+C, I don't know if I saved. Yeah, I have to save it. When I click on Ctrl+C, it says gracefully shutting down from my Ctrl+C, right? So after you do this, please make note of this. This is very important. I'm gonna paste the line of code in the chart. Just copy paste this line of code. This is very important in all of your projects. Of course, you can put any messages that you need. So it's like API dying. Cool. So once you've done that, let's proceed forward with scripts. Shall we continue? Okay. The next important thing that you will come across is scripts, this attribute in package.json file. Okay, in any package you will have certain scripts to be run. Scripts are nothing but npm. Let me show you a demo of what actually happens. So whenever I say npm install and I say any module, I'll say Prisma, for instance. We're not going to install Prisma, but let's say I'm going to install Prisma. Install is basically a series of scripts that will take the repository Prisma and get the files downloaded from the internet, put it on the node modules, create an entry in package lock.json, and it does a lot of things, right? So npm allows you to create your own custom scripts, and this is very useful when it comes to writing your own scripts and when it comes to testing. So usually when you test, you write a very huge lines of code on your terminal. You would probably run a series of commands. You might say git ignore or git add, or you might just continuously add in a lot of commands seriously. Okay, so that you don't need to do that. Instead, you can create a custom script that does that on behalf of you, right? I'll show you a demo. So let's say I'm gonna create a script called start. Okay, so whenever somebody does start my whenever somebody uses a script, I need my script to do this. They say npx Nodemod index.js. I think it's pretty straightforward when you look at this. So whenever somebody says npm run or npm start, you could either start a script using the name of the script, or you could say npm run and you can say start. So I'm going to go with the first. So npm start. Oh, oops. Okay, I haven't defined it yet. So I do npm run start. Wait,
Maybe you didn't,
what?
you didn't save the file.
Oh, cool. Thanks. I'm very bad at saving files. Cool. I do npm start and the server starts. So now you know you can write your custom scripts on package.json file. This comes in very handy when you have a lot of testing to do, when you have a lot of deployment or pre-scripts. We will come back to that later. We will be using a set of scripts that we might have to run every time you deploy or every time before you start a server, right? So all of that can be done using scripts, and we will be using a lot of scripts. I hope that's clear. So let's do something. We've written our first web server. We'll try to push this code to GitHub, right? So to do that, I think most of you have attended the GitHub bootcamp by the DMZ team. Anyway, I'm gonna give you a quick recap of how you can commit changes and push it to GitHub. Okay. So you go back to your source control pane, whether you say the message that you want to commit. You made a lot of changes and you want this change to have a message, so that tomorrow anybody, when they come to this particular point in your version control system, they might know this is the change that you made. So I'm gonna say created my first web server. Okay, I'm gonna commit it using the tick button. It says commit. Of course, not in normal cases as a developer, you would do it on the terminal. You wouldn't be, clicking buttons. And for the time's sake, we're gonna go with the easier way of doing things. So after you've committed your change, I want you all to click on sync changes. Sync changes basically pushes the code from your local repository and pulls back any further changes from the GitHub repository. So I told you, right, GitHub is basically a remote cloud repository. We need our repository from there to be cloned into a computer and vice versa. So we are gonna sync changes to GitHub. Just let me know once you've pushed your changes to GitHub, because a lot of the other things that we will be doing on the further workshops will be tracked on GitHub, as I told you before. And I need to see your progress so that I know where we stand, and I can look at your commits as and when you push, right? So please let me know when you push something. So if you have any problems, of course we will be here after the workshop. This is how you push, and I hope I made it pretty clear. You need not even write any code. You just go to the source control pane, commit your change and push. So every time I say push your code to GitHub, you do this, right? Am I being clear? Why is nobody talking? Okay, so let's get on with the workshop. So the next thing that we will be looking at is, so far we've just brushed up a few things that we did yesterday. We look at what endpoints are and how you can design a proper API endpoint, so that we learn a few standards of how you can basically write backend API endpoints. Okay. Is it glitching a lot? Because I feel like my screen is glitching.
It's flickering too much.
Okay. Let's do something. I think it's because of me moving my mouse a lot. Is that right? When I don't move my mouse, does it do anything? Jacinton? I can't hear anybody. Is Jacindan talking?
Yeah, da. Can't you hear it?
Yeah,
You can hear me, right?
கேக்குது, yeah, right.
The line's glitching, I think.
Okay, cool. Then I'll reduce my mouse movements. So let's get back to we were talking about endpoints, right? Okay. Is it still glitching?
Yes.
Nah.
Okay. Does it do now?
People.
Right? Okay, cool. So I told you that we looked at NASA's API, right? So it was like api.nasa.gov, and of course you have the HTTP protocol, and this is your backend server. So this was NASA's backend server. So let's take another example. Let's take Netflix, api.netflix.com. So let's imagine that Netflix gave us an API, and we are going to design a backend for Netflix. Okay, we're not gonna legit design develop an API. We're gonna look at how you can structure your endpoints in a way that it actually goes with the standards of building an API. Okay, so the first thing that you would normally do is identify the resources that you're gonna give access to an API's audience, right? So in case of Netflix, what data would a user would normally get from an endpoint? Any examples? No, nothing. What do you do in Netflix? What do you watch?
Video streaming.
Okay, list me the resources that you can get from Netflix. What are the information that you can obtain from Netflix?
The list of shows.
List of shows. That's good. That's a good answer. So you have shows. Then come on, it's that right on my screen, and nobody's even unmuting to shout that out. We have movies. What? Then
genre.
Our account details.
Okay, account details is basically the customers who are using Netflix, right? What if you want to get information about the customers or profiles? So that's that. What's the other thing?
Genre.
You have genre. Cool. So basically you get the idea. You have a lot of resources that you can get from from Netflix. So you have rating, you have titles, or let's stick with the major ones right now. Okay, so major on whole, you have shows, you have resources that come under customers, you have resources that information that you can get under movies, genre, rating. I think both of these will come under shows and movies, right? Doesn't that make sense? You have genre and rating, and this is not any cool. I hope this makes sense. So basically you have resources that are available on any backend, and as an API's user, you are going to talk to this backend through these APIs to essentially modify or read this resource, right? Let's take movies. So I showed you an example of how these APIs will be structured. It will be movies. So let's say I give a query, and I'm gonna say the movie that I would like is Hacksaw Ridge. So let's say my preferred movie is Hacksaw Ridge, and I want information that comes under Hacksaw Ridge, right? So I can query using a query parameter that we talked about earlier in the previous sessions. Okay, so here comes the catch. So let's just say it returns me a response like this. It has information about the title, and it says year of release. It shows me the rating, it shows me the description. Okay, cool. Okay, it shows me the description, and you get the idea, right? So you are able to get information under any resource using a locator. You are able to identify information using a route. So this is what a route essentially is. You have an endpoint, you have API. So our API is being served at api.netflix.com, and we have our resources that come under different routes. So in order for you as a user to get information from these servers, these APIs, you would use the appropriate routes. So to get information about movies, you talk to the movies endpoint. To get information about the shows, you talk to the shows endpoint. You get the idea?
Yeah.
Cool. And let's say, so far we talked about getting information from an API server. Like I told you, an API is not just for getting information. I told you can manipulate data on the backend, right? Any API allows you to manipulate, not just reading. It enables you to update, delete, or even write new data into a backend, right? So to do that, we will be looking at another concept. Okay, like I told yesterday, any browser request, fundamentally when you put it on the search bar, goes on a GET request, and any request is sent by an HTTP object. Okay, the fun thing about these HTTP objects are you have more than just the GET method of handling a request. Okay, so let's say we were able to get information using this endpoint on GET method. So HTTP, when you get further into HTTP, there are HTTP methods which you can use to talk to these APIs. So the most commonly used ones are the GET method and the post method, put method, and the delete method. It's the meaning of using these methods are pretty much in the name. So let's say I want to get some information from the same endpoint. Let's say I want Hacksaw Ridge, and I want to get information about Hacksaw Ridge under movies, right? So what do I get when I talk to this API on GET method? Can anybody guess? Can anybody guess?
You get all the related results.
Gets related results. It just gets related results
About the show itself, like date.
about what we queried, right?
What we want to
So we are gonna talk to the movies endpoint. So it gets me movies. Let's say we program our API to get me the movies or list of movies. Or if I have any query, let's say I give it title or get movie information by the title. So this is what you use get for. So I think it's pretty obvious beyond this point. So what does post do? Can somebody help me in that? Anybody?
Creates data.
Creates data. We have put endpoint. Come on, just read it out. We update a movie and delete a movie. So you understand that there are other methods than just get method, and your browser can only do get methods. Of course, your browser essentially does all of this under the hood. So we will be looking at how we can use JavaScript or our programming language to make all of these to handle all of these other HTTP methods. And we will also be looking at how you can send requests to these APIs on methods other than get. So far we looked at how we can send a request on the browser. So when we put api.nasa.gov on our browser, we were able to get information. So on the other hand, when you want to put any information into the backend, so let's say you have Netflix movies and you want to put a new movie information through the API, so you would use post endpoint, and you cannot do that via the browser address bar. To do that, we are going to be using a tool. There are like tons and tons of tools available on the internet, but we will be using Postman. So Postman is a very commonly used API testing platform. it's not just an API testing platform, it's also an API documentation platform. Okay, so far are we good? Do we have any doubts? I mean, we covered a lot of basic networking concepts. It's not even networking concepts, it's basic web concepts. So are we good? Shall we continue? Cool. So I hope all of you installed your Postman. So the next couple of minutes will be of us learning how you can document your APIs, or how you can make requests to an API endpoint, right? So I want all of you to open up Postman quickly. And I told you to create an account on Postman and get it ready. I hope all of you did that. Once you open Postman and sign up or sign in, you get a workspace which looks similar to this. You wouldn't have all of this, but you would have something similar to what I have on my screen. Just let me know when you open Postman. Okay, quickly get back to my screen. So I've been telling you about all these APIs, right? You can get information about let's say movies. You can get information regarding of whatever API you're requesting to. So I talked about Netflix APIs, we talked about NASA's APIs yesterday, and we even talked about Pattarai's own APIs. Okay, so in order for me to get information, I need to know how my data request should be, right? Without me knowing what are the available endpoints, what are the data that I can retrieve from any endpoint, I cannot do much with an API, right? So let's say I give you Netflix APIs. You don't know what routes are there. You don't know what information that you can get from that endpoint. Would you be able to do anything with that? You cannot build a front end without knowing what can be retrieved from an endpoint, right? You cannot do anything without knowing what can be done with an API. To solve that, people usually give API documentations. This is very, very important when it comes to backend web development. You need to create documentations for your APIs every time you test it, every time you deploy on your backend, so that the front end guys or anybody on the internet would be able to understand what you're trying to give as a backend, right? Am I being clear here? Does everybody know why we need an API documentation? I mean, just click on the I'll show you a sample of how these API documentations would be. So my favorite API documentation is, let me get clear with this. So Stripe is a payment gateway. Okay, I don't know if many know it. You must have heard Razorpay, right? So Razorpay's alternative is Stripe. So Stripe is used globally by people for handling their payment, and these people at Stripe, they give you their API for you to add payments or get information about payments, transactions, send invoices and things like that. Okay, so without me knowing what is offered by Stripe, I cannot do much. So to solve this, I told you have API documentations. So let me Google Stripe API documentation. Usually you call it docs, and they have an API reference. Whenever I open it, so you can see essentially they are showing you what they are offering. You can get information about payments, you can get information about the business operations and the other things. So they've categorized things that you can essentially get from any API. So let's get started with payments. So let's get to invoice, And for instance, let me show you what this API does. You can see, right, how you authenticate with an API. So let's say you have balance. To talk to to this Stripe API and get balance under a user, you ping the balance route. So you have api.stripe.com/v1/balance. So whenever somebody talks to this endpoint, you can either request with these attributes. You can either give them an issuing hash, and it gets back this response. So now people know how you use this API, right? You want people to use your API, not just build an API and shelf it on the cloud, nobody using it, right? So whenever you build an API, you build it to be used on the front end. So to do that, you build a documentation, and your documentation has 3 important things. One, the name of the endpoint, right? The name of the endpoint and the method that you're going to use on that endpoint. So let's say you have get/balance, you're going to retrieve balance from it. So when you have post/balance, you're going to post balance. You're going to post information to the balance resource. So this is fundamentals of REST API concept. Okay, so this is basically how you order your APIs and things like that. And so far, the next other information that you would normally require in an API documentation is you need to define the request object, and you need to give an example of how your response would be, right? You need to show the user how your response would look like, so that they can take this information, map data from this and show it on the front end, right? Am I being clear? So I think we have a message that says recap the last point. What was it? Okay, I hope I cleared that. Okay, we are almost at 7, and I think we covered the endpoints. Cool. Okay, now just get back to your VS Code. We'll quickly do something. I'm gonna quickly get rid of this file. Get back to your index.js, and let's redefine something just for an example case. Let's say I have an endpoint that says cars, and instead of sending hello world within the h1 tag, let's say I'm going to return some actual data. So I'm going to return the cars that are available. So I have a list of cars, of course, essentially an array of cars, and so whenever somebody pings this endpoint on get method, what would they get? Come on, just be quick, just giving you out quick answers. What would I get if I ping the cars endpoint?
The list of cars.
The list of cars. Cool. So far we've been looking at requesting using the browser. So let's get started with Postman. Open your Postman, and after you open the Postman client, you call this a Postman client. The first thing that you do is you click on the collections tab. Okay, just make sure you are on the collections tab. Click on this plus icon. So you create a new collection. So call that workshop. I'm gonna be precise, saying ExpressJS workshop, and you save it. Okay, you save it by pressing Ctrl S. After creating the workshop endpoint, after creating the workshop collection, right click on the workshop collection and click on add request. Okay, of course you would have a default new request in it, so don't do that. Just right click on the collections and click on add request, and I think it's pretty straightforward here. what would you do? What would you put in this request URL? Can somebody help me out? Come on, be quick.
Localhost.
Yes. So I put localhost, and it's on port 5000. And what endpoint am I gonna be talking to? Cars. Perfect. We have cars. So we have cars. So the moment I click on get cars, okay, it says the server refused to connect. There is no server running. Could not send a request. What would be the problem? I think I didn't start the server. Yeah. So you start your server, get back to Postman. Now try requesting. What did I get back? I got back the result. I got back the response, right? This is interesting. So far we've seen it on the browser, and now we've been testing it on a Postman client. So the other important thing that you do whenever you test APIs on Postman is you document along the way, right? Usually people have a tiresome process of documenting their APIs. After doing all the testing, they will hire somebody called API documentation experts, and they would come and analyze all the API code. They will write documentation on their own. So that's very tiresome, and nobody wants to do that job. It's like totally a waste of time. So instead, whenever you test an API, you create a documentation along with it. You do that by this. So you created a new request, and whenever it's a very good practice. So whenever you create a new request, rename it to whatever request that you're gonna create. So this endpoint was cars, and let's say it gets me a list of cars. Be precise of what you're gonna get from the endpoint. Okay, so I'm gonna save the request name. It says cars, and it says get endpoint. On talking to the cars endpoint on get method, it gets me a list of cars. And the other important thing is, so far we've been testing and we did not save this response, so that people know what this endpoint actually might return. So to do that, you click on these three dots, right? You click on those three dots and press add example. Okay, so what this does, it creates an example of your response, so that whenever people come to the documentation tomorrow, they will know. So you might be testing with a lot of other data. Your response might keep changing, but you need some sort of a response for the front-end developer to stick to, right? So now the front-end developer will come to this piece of code. They will understand that, okay, this is what the data is going to come back, and I'm going to use this endpoint. So whenever I talk to this endpoint, I get data like this. So I'll map my data along. Yep. We have some message in the code chat. Okay, so yeah, I think you get the idea, right? So this is how you document an API. So far, do you have any questions? So we talked about the HTTP methods, right? So how do you do that on Express? So that's pretty straightforward. And what are the other API? What are the HTTP methods that we discussed? We talked about post, we talked about put, we talked about delete. So let's say I'm going to define a post endpoint for cars. And it handles a request, and it sends back a response, and it does that in this file. I mean, in this handler. Missed out a comma. Yep. Just let me quickly be done with this endpoint, and I'll explain what is actually happening here. Okay, the moment I clicked on save, the server restarted, and now I have another endpoint that handles post requests, post HTTP methods on the endpoint cars. So any guesses of how we can talk to the endpoint on Postman? It's right there on the screen. You have this drop down that says get, right? If you look at this drop down, you have hell a lot of HTTP methods that you can use to talk to your servers. So let's say I'm gonna create a new request, because this is essentially a new request. This is not at the same endpoint. So I click on add request and I say this is the cars endpoint, and here I'm gonna create a new car on this endpoint. And how do I talk to this endpoint? I talk using the post method, because that's relevant, right? You post data, you don't get data and call it an endpoint to create a new car. So of course this is going to be the same endpoint that says cars. And now the cool part is, where would you put the data? Where would you put the car's information, right? So far I've been telling you that you can put information through query parameters. Do y'all remember any one way where we can write data to the endpoint? Send data, send any piece of information to the server. Does anybody remember? We did something like question mark, and we did something, right? Does anybody remember that? Nobody?
Question mark title is equal to Hagrid.
Yes, right.
Queries.
So yes, so in order to talk to a server, in order to send information to an API, there are multiple ways you can do that, right? Basically all of this information gets encoded into a request object and gets sent, but the way you structure it differs. And one way of doing it is by query parameters. So you would have seen this in YouTube, where you have youtube.com/, let me just quickly show you what happens when you go to YouTube. So whenever you click on a video,
you have 10 minutes.
It says /watch v is equal to the video ID. So it essentially shows you the video ID. So whenever somebody requests the watch endpoint on YouTube, under giving the video ID that says yada yada yada, YouTube is able to understand that request, and it is able to send back a response of the video, right? So that's what we are going to do here. Our server needs to get an information, and our cards API would need data, right? So we can either do that, but if you get back to the code, let's try that. So you send in data, and I'm gonna give the name of the car, or I'll say car is equal to Chevy. Okay, and I send a request. It says success, but let's log what happens. Let's see what was there in the car variable. Okay, I again click on request, and this time just look at the server. It says undefined. It means that my request, my query didn't pass along to the server, right? The server was not able to understand my request. So the problem here is our request object, right? It has different ways of structuring the data that we send, and whenever you send data on the query parameters, you have to make changes to your backend so that it gets the query endpoint. To get any query data, you do this request.query. Okay, now whenever you look at request.query, this will have the data corresponding to car. And let's try now. I click on send, and now you are able to get Chevy on the server, right? So this is how you get information on the query. But there's a problem here. Okay, let's say you are building an API for a bank, and you cannot send potential account information or account passwords on the query parameters, right? That's very dangerous. Do you get the point here? I mean, let's take a quick break. It's like been a long time, and just tell me, so far, is it going good, all good, or should we taken some 5 minutes break before continuing over to the next session? I think let's take a break. Just go get some water. Yep, we'll do that. Shall we? Cool. Just take some 4 to 5 minutes. Just be right back immediately. We have a lot to cover, and it's gonna get interesting after this. Send the code here. Yeah, I'll do that. Don't push this code to GitHub. We have a lot to do. This is just, we are just playing around with Express. I will explain this endpoint later when you come back, so don't be worried about not understanding the code. Yep. Jacinton, is the 5-minute over? Is the 5-minute break over?
Yes, we can start.
Yep. Cool. Where were we? Okay, let's get back. Can I get a yes? Can everybody just unmute and give me a hi? Let's go from the top. Abarna, Abhishek, just go on from there.
Hi.
Hi. Please be lively. Yep. Hi, Abhishek. Hi.
Hi.
Hi, Hanisha, and hi, Anton. Okay, I think he's still on the break. Askin.
Hi.
Hi, Askin. And yeah, quickly, we have a lot to cover. Even if the person prior to you doesn't open, just go on. Sigro.
Hi.
Hi.
Hi, Phoebe.
Hi, Brighta.
Hello.
Hi, Crispin.
Hey, baby.
Hi, Danny. Hi, Divya.
Hello.
Yup.
Hi.
Hi, Gabriel. Come on, quickly. Why has it stopped? Okay. The next person at least open up. We have a lot to cover. Jacinton. கேக்கலடா.
Yeah. Hello, Kevin.
Hi.
Jeremiah's here, I think.
Yep.
Hi.
Hi, Jeremiah. Hi, King. Okay, எல்லாருக்குமே hi. I think we are back on the track. Let's get started. Let's not waste any more time. I think all of you are clear with what we did so far, right? We created a web server that handles a GET endpoint. We created another endpoint that handles the post requests, right? So our cars endpoint was able to get information from the query parameter, from the query URL, right? So we had a URL which was able to get resources under cars, and the car that we requested was Chevy. And on your server, we were able to log that piece of information that was coming from the client. So you have a server, you have a client, you were able to communicate to a server from the client, and you were able to send information to the server. We did that, and we were able to prove that you can get information using the query parameters. How you do that? You do request.query.car. So how do you send information that are really confidential? You don't want your email and password to be sent on the URL, right? So to do that, normally in JavaScript or in any other programming code, they send this information, this confidential information, or any sort of information on the body. Any HTTP request object has another structure within it called the body. So this body is basically your payload, right? Imagine it as a rocket, and you are essentially sending this piece of payload to the server. So you can either send it in different forms of data. So basically, whenever you send information, your server must be able to understand, okay, your body is in this form, and I must be able to parse that information using this parser, right? So if I'm gonna use a form encoded body, I'm gonna obviously put form, and of course when I send information through the form encoded body, I must be able to retrieve information back on the server on the backend using request.form. There are different ways to handle different forms of request queries. there are different ways of handling different request objects, right? That's what I'm trying to mean here. So we'll try going with raw, and I'm gonna say it's a JSON object, right? Let's say I send in car, and along with the car's name, let's say I'm gonna say Mustang, and let's try something new. We have the car's date of manufacturing. It's gonna be 2001, and cool. So we have some information to be sent to the backend. So let's try sending. Of course, I have to remove the query object. Let's say I don't have a query object now, and I'm sending it via the post, and now my data is not being sent on the query parameter, or not on the URL. I'm sending it by the body of the request object, right? So let's see what happens. Again, we have undefined. It's because we try to get the information of the car by request.query, and this object does not have the body. To get the body, you do this request.body. To be more precise, you can get the actual payload nested within any body by referencing its name. So right now I have car and I have date of manufacturing. So let's say I want to get the date of manufacturing and log it on the console, right? So I save it and I click on send. Okay, that's some error. Let me do this instead of this. Okay, let's just try logging what this body has to offer. I don't know, we are facing some problems here. So let's say I save them, I try to log the body, let's see what happens. Again, it's undefined, there's no body here.
I didn't save it.
Oh yes, perfect, thanks. I didn't save it. I have this terrible practice of not saving my files and expecting output. So yes, I save, and let's undo. But it should still work. I have the cars endpoint, I have this data, and it's on JSON. It seems to be the problem. Let me quickly try something else. Okay, so I figured out the problem. Okay, so the problem is out of the box, Express won't let you parse JSON, right? Usually whenever you send data to the server, it's in the form of string. It gets stringified whenever you send it to the server. So whenever I say stringified, it's just plain text. It doesn't know basically JSON is a data type, and the server does not know to understand this JSON notation, right? For your server to understand this JSON notation, you use a middleware. So I'm not gonna talk deep about, in depth about middlewares. We will get back to that in a further stage. So right now, just know that a middleware is a piece of code that's like, it's essentially a middleware. It's like a middleman. He takes in the request, does something on the request, sends back to the server. So your server will be using the express.json middleware. So what this does is it takes the request object, gets the string payload out of it, it converts it parses it to the JSON. If it finds any JSON notation, it sends back to the endpoint whichever it got requested to. So our endpoint, we requested this /cars endpoint on post. So our data would have been gone to this middleware, it got parsed to JSON, and now we were able to read JSON data out of the box. I mean, am I being clear here? Did you get what middlewares are? We won't be getting into defining middlewares, not yet, but we will be doing that on a further stage. So just understand what middlewares are. It's just a middleman who's gonna take your request, do some sort of job on it, and he's gonna send it back to the server for further processing, right? So he's like the middle guy. Am I being clear here? Cool. And of course, you can get any information nested deep within it. So, or you can either just do anything with it. I think it's pretty clear, right? Whenever you send data through the, I think it's still glitching. Cool. So whenever you send data to the through the Postman client, you send your data like this, and you'll be able to get that data from here. And what do you do after getting that data? Right? Here comes the best part. You use the API to do something, right? You're not just gonna use any API to just log things on the console. So you take the data, you write some piece of code that we will be doing shortly. You will be writing a few pieces of code, and this code will be responsible for putting this data this piece of data into the database, right? You have information about the car, you have information about the date at which it was manufactured. You take that information, you put it in a database, and to do that you have a few lines of code that we will be doing shortly in a few minutes. So this is gonna be here, and after you write into the database, you say success, I successfully wrote data into my database. So this is what we are going to do over the next hour or so. Okay, so quickly let's get into database. So far you've understood what APIs are, you've seen a few endpoints, and I also told you there are many ways you can talk to an endpoint, and we talked about the 4 basic endpoints: get, post, there was put, and I also talked about delete. And does anybody have any guesses of how you can define a put endpoint or a delete endpoint? Does anybody have any guesses? It's pretty straightforward.
Server.delete.
Server.delete. How do you put data? How do you use the put method? Come on. Server.put. Perfect. So now you know how to talk to an API using different HTTP methods, and you know these are responsible for different purposes. So you call this CRUD, okay? CRUD, CRUD. So CRUD is basically create, read, update, and delete. Okay, it's an abbreviation of this: create, read, update, and delete. And these 4 operations are what you'll be basically doing on any database. You will be creating records in a database. You will be reading data from the database. You will be updating things that are already existing on the database, or you might delete things on the database. So you have 4 basic operations that you might do on any database, right? So we will be using these different methods. So whenever you post data, it implies that you're gonna create a new record on the database. So it's understood that you're performing the create operation on a database. So whenever you create something, what HTTP methods do you use? You use the post method. So when you delete something on the database, you use the delete method. So I think it's pretty straightforward, and it's based on relevancy. So let's get started on how you can talk to databases and what these databases are. So quickly, can somebody tell me what database actually means? What is a database? I mean, we are going to get into a few minutes of lecture, a few minutes of theory, and let's get right into using these databases. Come on, be quick. We have more than half an hour left.
Collection of data.
Collection of data. Collection of related data, right? So you have Netflix's database. What do you have in Netflix's database? You have movies, you have TV shows, and all that information that pertains to Netflix. Any application that you build, any application's database would have data relevant to that application. So we have, let's say you build a blogging platform, and the database for that blogging platform would probably have posts. It would have a collection of comments. It would have related information about the users who sign up in that blogging platform. Yeah, you get it, right? So there are actually different types of databases. Okay, you now know what a database is, and let's slowly get into the different types of databases, right? So has anybody come across these fancy words, SQL and NoSQL databases? Anybody? I think SQL is there on your 12th standard syllabus, so you cannot say no to that. Is everybody familiar with SQL databases? Okay. For the ones who aren't familiar with SQL databases or any databases, usually in the conventional database system, in any conventional database system, people usually store information about resources in rows and columns, right? So let's say you have information about users. So you will have a table of users, and this table will contain columns. And what these columns will have is essentially you'll have the name, you'll have the user ID, you'll have the user's profile picture, or any information pertaining to the user. So let's say you have first name, last name, and so on, right? So you have a collection of records coming under a single table, and here all your information is stored on rows and columns. Columns are basically the attributes, and records, the rows are basically the records, right? So if you want to add the second user, let's say you want to add a user to the database, so you take a table, you add a user, and of course it creates a new record for each of the columns. So for each column you have attributes, and these attributes could be the user ID, the username, and so on, like I told. So I think you get a pretty good picture of what these conventional databases are. And over the past few, I think it was around 8 years back, and there started this fancy hype around NoSQL databases. Okay, the problem with that, it's not a problem, it's more of the preference, right? So the people started, normally you would do this. To talk to these API, to talk to these databases, you would need some sort of a language to talk to this system, right? Or any database system. This language was structured query language, SQL, and it would probably look like this: select all. Let me just quickly annotate what I'm saying so that you better understand what I'm doing here. And any SQL query might be familiar to you. So it would be like select all the data from star, basically means all, and select all information from the users table. So it would get me information like this. It gets me a list of information that says ID, name, email, and so on, right? So this is how you talk to a conventional relational database, and you get back a list of records that come under the users table, right? So this was a relational database where you have all these tables and columns. But the change in NoSQL is you don't really store data in a tabular fashion. Here you store all your data with key value pairs of. Here you store it as collections of data, right? So let me show you how it basically looks. So if you look at the picture that I'm showing you, right, you have SQL, a database. This is a users table where this is how it looks on a SQL database. For example, you have MySQL database, and these are different softwares, database softwares that offer database solutions. So if you look at a SQL database on a users table, it will look like this. It will have an ID, and it will look like a table. But on the other hand, if you look at NoSQL databases, you will be storing information like this. You'll have collections of users, you'll have collections of movies, you'll have collections of TV shows, and inside this collection you will have all your data organized as documents, right? So all these collections are nothing but, you can think of it as relevant or related information. So you have a collection of users. It means that you have documents of users which have unique object IDs to it. So basically you're collecting information, like treating them as an object in NoSQL database. So that's one very important significant difference between a relational database and an object-based database. And one famous giant in SQL databases is Postgres, right? I think many of you might have heard the name PostgreSQL, and this was developed by the Postgre company, and this is widely used by enterprise grade companies, and this is like very highly scalable, and it has a lot of other cool features. Rather than just sticking on to MySQL, you might as well move to this Postgres database, because it has JSON support, it has a few other tips and tricks that you can use to make your development faster, right? So in today's workshop, we'll be looking at how we can get a Postgres database set up on our Express API. So what we will be doing is, we will take information in our API, we will be storing it in a database, and we will be writing another API endpoint that is able to retrieve information from this database and show it on the front end. Okay, front end being the Postman client. Shall we start? I mean,
Yeah.
perfect. So I asked you to create an Heroku account, right? Morning, I think I did in the noon. So I hope all of you created an Heroku account. Heroku account. Heroku is a platform where you get to deploy your apps. So they have a decent service where they give out free Postgres solutions to any developers. They have a free plan, and we are going to use this Postgres database for our project now. So head over to heroku.com and do this. When you sign in, you'll come to this dashboard, and on the top right you will find this new button, a button that says new. Click on that and create a new app. Call it Workshop DB. Of course it's not available. I'm gonna call it something else. I'm gonna call it Skywalker DB. You can name it whatever you want. So give it your name and create a new database. Create a new app. After doing that, let me know. And for the region, you choose Europe, and if you've not done it, so just choose Europe. We are doing this because Europe's servers are pretty faster than the other server, the US servers. So create a new app. Just let me know if you're done. React to the message quick, because we don't have a lot of time. We will have to get into Prisma and all the other new technologies that we will be using. Cool. After, I think we have 7. Has everybody logged into Heroku, or are you finding any trouble? Let me know. We'll get started when we have 20 responses. Come on, quick. We have 12. What about the others? What's happening? Come on, open up and tell me, so that people know, we will know what's happening, and we will be able to help you out. You are asked to go to the Heroku website, sign up, head over to the dashboard, create a new app, call it your name-db. Do that and let me know. For the ones who are struggling to follow up, you can always refer the stream. So if you miss something out, head to the stream, rewind, do that and come back. Okay. Cool, we have 16 responses and we have almost 35, 36. Please get it soon. I'm gonna wait for another 5 response, 5 reactions. Yep, 3 more. Okay, for the ones who have successfully signed into the app, and make sure you're there on your apps page, right? Click on your app and just verify if you're on your apps page, and go to the resources tab. And if you, okay, let me quickly delete this. Yeah, head over to your app, go to the resources tab, and if you find this field that says add-ons, type in Postgres. You'll find Heroku Postgres. Click on that. The moment you click on that, a pop-up will open. It says Heroku Postgres. Do you want to order this? And make sure you are there on the hobby dev plan. It's free. You need not pay anything. Just make sure that you are there on the hobby dev. Leave it on default and click on submit order form. Once you've done that, you must have been provided with a Postgres DB for free, and of course you can use it for any development that you need. If you want to build any projects on further, you can always use Heroku Postgres DB for free, as long as you abide to the rules and regulations. It's totally free. Just go and use it. So once you've done this, let me know if you created a DB. So right now you must have a Postgres instance for you. Right? We have 8. Come on, be quick. We have a lot to cover. It's slowly reducing the reactions. I don't know what's happening. I mean, if anything's wrong, let me know. We have 15 reactions. I'm going to proceed. So after you've done creating a Postgres instance, click on Heroku Postgres. Click on the text that says Heroku Postgres. It should open a new tab, and if it didn't load, refresh the page. Cool. So once you are here, head over to the settings tab. Right? In the settings tab, you'll find your database credentials. So what are these database credentials? So these credentials are what you will be using to connect to a database, and you need to keep this safe. And there's another important thing that we will be discussing about keeping your credentials safe and not putting it on GitHub, because yeah, we'll talk about that in further steps. So I want you to click on view credentials. Right? Once you've done that, copy this URI. Copy the long URL that says URI. We need this to connect to our database. Copy that. After you've copied that, I want you to open Beekeeper Studio. Right? We installed Beekeeper Studio yesterday, and I asked you to install Beekeeper Studio. Let me know if Beekeeper Studio is open and ready to use. We have 7. Ten, 12, come on. Cool, I'm going to proceed. So once you've opened Beekeeper Studio, it prompts you to create a new connection. So you choose Postgres and it should open a new connection dialog box. Okay, and if you notice on the top right corner it says import from URL. Click on that and paste the URL that you just copied. Click on import. Do that and quickly let me know. And after you've done that, I want you to enable SSL on this connection. Okay, you have a toggle switch that says enable SSL. And this is another form of security that you enable on database connections. Heroku expects you to send request to the database connection using SSL. It's just another security concept. We won't get into that now. So just enable SSL. And after doing that, I want you to save this connection. Give this connection a name. You can call it Heroku or call it whatever you want. I'm gonna call it HerokuDB. I'm gonna give it a new color. I'm gonna save, so I can find my saved connections so that I can connect it whenever I need. So once you've saved your connection, click on connect. It should open your database on this database viewer. Make sure you've done that. Are you in? Have you successfully connected to your database? React to my message. Cool. So again, in any relational database, you have data stored as tables, right? So in order to create a new DB, we have a new DB in our hand. In order to start using this database, we need to define the tables, right? Because SQL, in the name itself, it says structured query language. We need to structure our database's schema in a way that we can start using the database, right? So any database will have a structure in terms of relational databases. I'm talking about in any form of SQL databases. So in order to create that schema, or schema is basically the plan, right? We need to plan the database. So now I'm going to create a new table and I'm going to call it users. And this table will have information about the users who will be signing up. And I'm going to do this, and if you want, you can do something else. You can probably name it cars, and I want you to put relevant information on the columns. So in my case, it was users, and I'm going to say there's ID in my users. There's a column that says created at. I don't need this at the moment. I'm going to delete that column. So let's say I have another column that says username or just name, and I have another column that says phone number. Cool. I think this is enough for just explaining what is happening under the hood, and let's stick to this. After you defined your columns, after you're done with all your table name and the data type of what columns and the column data type, just click on create table and it should create a new table for you with the defined schema. Just let me know if you've created your first table. Just be quick, don't over engineer this. Just be simple, do some basic table and put some columns in it and be quickly done with it. You can probably call it cars, you can call it movies. It can be a table that denotes something. I just want you to create a table. Okay, do that and let me know. Be quick, we have another 10 more minutes. We have 7, and yes, be quick. I mean, the count is slowly reducing. We have almost 35 participants, and I can see 20, 19, 14, 12, 10. What's happening? Anybody want to let me know. Let's have a quick attendance. Okay, if you're there, let me know. Okay, I'm gonna proceed anyway. So after we created our schema, we have a table, but we don't have actual data in it. We define the columns that our table might be having. We structure the database, right? Now we will be putting data into the database. How you do that? You use the same client. The Beekeeper Studio allows you to define the schema as well as put data into the database, right? So when you right click on users table, it prompts you to view the data or view the structure. Click on view data. When you click on view data, it should open the table with empty columns. I'm gonna zoom in a little bit so that it's clear for you. Let me know once if you opened. Yep, I hope everybody's inside the table. Now if you look at the bottom, you have this icon that says plus, right? Add row. I want you to do that. I want you to create a new record. So let's say I'm gonna give my user an ID of 12 and I'm gonna give him a name Clark Kent. I'm gonna give a phone number. And cool. Once done, click on apply. So once you've done that, you should see, whenever you refresh the database, you should see your data in the database. We have successfully created a record. Okay, but here's a catch. So far we've been doing it on a studio, right? This is basically an app that lets you put data into a database or manipulate a database structure. Now we will be using Express, our backend, to do this on behalf of us. Okay, we will be building an API that talks to the front end, or that is able to listen to the front end and make changes on the back end, which consists of this DB. Okay, we have a DB on Postgres, and we are going to build an API that can talk with the front end, that the client, and do some changes on the Postgres backend, right? Now when I say backend, here I mean the database, the web server, and everything associated with the backend, right? So let's get right into it. Now you understood what this database looks like. You have tables, you have columns. Now we will be getting into something more interesting. Okay, the problem with using tables is it's really hard to maintain, and whenever you write a query to get information, normally you write a query. So let's say you want to get all the users, all the records under a user. You would write something like this, and you would run the query, and you would get the response, and you'll get a list of records that match that query. Okay, but when it comes to writing complex queries, like let's say you have multiple tables and you want records that are present in both the tables. This example would be take Netflix. You want Star Wars. Let's say you have Star Wars, and you want all the movies and you want all the TV shows that pertain to Star Wars. Okay, in this case you cannot use a simple query. You need to write a query that takes information from the TV shows that match Star Wars under the genre, and you'll have to match the movies that match under Star Wars under the same genre. You have to do some sort of a processing within the database before actually getting information in what you require, right? This gets really tough when you talk about big apps, and when you talk about huge scalable apps. To reduce that, or to eradicate that, we introduce something called an ORM. Okay, let's get started. So far, do you have any questions? So far, do you have any questions in what we did? No. Okay. We'll quickly set up our ORM, and I'll tell you what an ORM is, and we'll quickly set up our ORM, and tomorrow we'll get started with actually using the ORM to do the CRUD operations. Let's get started. So what's an ORM? So when I told you have a table which has related records, and I told you that when you have things, when you map things as objects, it's more easier to get data, because in objects you have keys that match for a value that has a value. So whenever you say you want to match records under a particular entity, it's more easier when it comes to accessing it on key value pairs. For those who've done it earlier on Python dictionaries, you might find Python dictionaries more easier to use rather than declaring an array of related data, right? You have an array of books, you have an array of authors. Relating both of them doesn't really have any relation. But when you define it as a dictionary of key value pairs, you can probably nest things into it. So let's say you have a book, and you have the key that says author, and you want to get the author's address. You can nest the information about the author within that object. So here you talk about key value pairs, you talk about objects, and things are way more easier when it comes to complex querying of data. And when in terms of complex queries, I just gave you an example of getting information of Star Wars from TV shows, from movies, different collections basically. Okay, so we are going to be introducing a new concept called an ORM. When an ORM is object relational mapper. Okay, so ORM basically means object relational mapper. Okay, so what it means is you have a relational database, you have a relational entity, you map it to an object. So if you look at my screen, you have this users table, but you can also write it as in terms of objects, and this is what we do in an ORM. You take an existing database, you take an existing model, you take an existing relational database, you model an object, so that whenever you push and pull data to the database, you have some sort of an object notation, which makes it easier for you to query data, right? I mean, am I being clear here, or is it really not getting into it, or should we proceed? You get what an object relational mapper does, right? You have a relational database, you have rows and columns. Instead, you take rows and columns, you put them into an ORM, and an ORM takes care of it and converts into objects where you have keys and values rather than rows and columns. You get the idea? Anybody?
Yeah, Fabi.
Cool. When we actually start using it, you might have a better understanding. Okay, so let's get started. A few famous ORMs are Type ORM and Prisma, and I would personally recommend using Prisma because Prisma is very user friendly and anybody can get started right into databases without actually knowing the crux of databases or even advanced database paradigms. Okay, so what we are going to do, get back to VS Code and do this. Stop your server. We are going to clear out a few code. Okay, I'm gonna stick with the same. Let's say I want you to put this piece of code. You do npm install prisma --save -dev. I want you to install Prisma as a dev dependency. Do that quickly. I'm gonna paste the command in the chat. Install Prisma as a dev dependency. After you've done that, I think it should be done. It should take a couple of seconds. Once you've done that, just react on the message. Or I think we are beyond time. Just look at my screen and make sure you follow that afterwards in your live stream or whatever. So just look at my stream and try to understand what's happening here. Okay, we have installed Prisma. the next thing that we do is we need to initialize Prisma in our project. Okay, we install the module, we need to initialize. In terms of Express, the web framework, we initialized using this piece of code, right? We imported everything from the modules and we initialize it on our main file. But in case of Prisma, we are gonna initialize it and it's gonna do a few tasks under the hood, and I'll be explaining further about the tasks that will be happening under the hood, but just get along with me. The next command that we will be putting is npm prisma init, npx prisma init. So if you notice, here's an interesting thing. It would have created a new folder. I mean, does somebody want to talk? Okay, it creates a new folder and you have a schema defined in it. Right now you don't have anything. Right now the only piece of code that you have in the schema is a data source and a generator. Okay, the very important thing is in Prisma is you can have multiple database sources. It means that in a single API, in a single app, you can use multiple databases. This is very it's a very cool feature when it comes to Prisma, because you can use a NoSQL database as well as a SQL database in a same project. Not many frameworks allow you to do this. Not many modules allow you to do this. But Prisma allows you to have multiple data sources so that you can use any of these data sources for your clients, right? So what we will be doing is we will need a Postgres client, and basically we have a Postgres data source. But if you look at the URL of our database, you copy the URL and it says env, and we'll talk more about why we need env files tomorrow. But just know this, we will be putting our URL in this file. So initially we copied our Postgres URL, you copy that again, you head back to this env file and you paste it. You save that file and done. So our data source would be able to get this database URL from this env file. Okay, that's what we've done here. It's nothing new, it's all what you know. But the very important thing is we haven't yet mapped our relational database to objects yet. And it means that we haven't modeled our objects from the database. To do that, I'm going to do something over here. The command to do that would be npx prisma db pull. So this command is going to talk to my DB, pull all the information, all the schema, all the structure in the database, pull it inside my project so that it can start mapping this table into an object, right? We don't need rows and columns, we need keys and values, we need an object notation, right? It's going to take our database information from Postgres, it's going to pull information and put it in our project directory. So when I click enter, it starts doing that. It is able to read the information from the env file, it's able to talk to the database, and now when I again open the schema.prisma file, it says model users, and I didn't type this code, it fetched it from the database. So it is able to read the schema from the Postgres database and automatically generate the schema for you, right? In olden days, in all these monolithic software development paradigms, you have .NET and you have all the other heavy programming languages, like not the heavy programming languages, you have heavy programming frameworks like Django, Flask, and so on. Over there, when you want to do this object relational mapping, you would have to do it all by yourself. You will have to write this piece of code, you will have to model your database again in your project. But Prisma makes it easier. It automatically pulls data from it automatically pulls schema from the database and puts it in the project for you. So now you need not type all this piece of code to start using your database, right? So the next step would be creating this mapping. We created the mapping, we have a model ready, we need to start using this, right? To do that, you do npx prisma generate. I'll tell you what's happening here when I do this. Cool. So far we've modeled our database using npx prisma db pull. We pulled database from the database and we stored it in schema.prisma. Okay. So in order to start using these objects, in order to start using methods that are available on the database or perform functions on this database, we need to define a set of we need to define a client. We need to generate a client that can talk to this database using Prisma. And essentially when we do npx prisma generate, this the last command that we did, npx prisma generate, this created that client for us so that we can import it in our API file. So now I can just do this import. I can say prisma client from prisma client, right? And now I can say prisma. I'm just gonna initialize that client, and now it's all done. In just a few seconds I'll be done. And I told you this is where you'll be talking to the database. I'm gonna say prisma and what was the information that we had? We had ID, name and phone. So let's say I have ID and I'm just gonna do a quick code and I'll explain it further. I just wanted to show you how Prisma actually works. So let's say I give some random number, and it's an integer. I'm sorry. And now instead of sending success, I'm going to return the response. Done. So the moment I start my server, npm start, and I head back. Wait a minute. It says I cannot use input statement outside a module. Okay. Cool. So let's try hitting that server. It's users, and I send in I don't send any information because I'm not going to read anything. Let's just call this API. I send. Okay, there's already an endpoint. Okay, that seems to be a unique constraint problem. Okay, I'll fix this and let you know. But just understand the things that are running behind, because I kind of feel like I rushed a bit. But I just wanted you to understand how easy this would be as a developer when it comes to building APIs using Prisma. Okay, since we don't have time, it's almost 8:10. I don't want to keep you waiting. It's been almost 2 hours, and we'll get back to using Prisma tomorrow. And I just wanted to know that so far we've covered generating Prisma schema on a project. We will be recapping whatever we did until the last 10 minutes tomorrow. Tomorrow we'll be looking at how we can authorize our endpoints, how we'll further use Prisma and make things easier. I don't want to rush things up and get into a mess. So let's stop here. I hope everybody got what we've been doing so far. So don't worry if you've not coded anything yet. I'll be giving you an assignment. I'll be putting all the code on my repository and sharing it later by tonight. So yep, thanks for coming. And Jacinth, do you have anything else to say? Tomorrow we'll meet at 6. So we'll be done with all the other things that we left out for today. So I want you to try installing Prisma and setting up your models. Just do that before you come tomorrow and we should be good to go. Okay, is there anything else, Jacinth?
I think maybe you told everything. So yes guys, we'll post the feedback form. Don't forget to fill that. Yep.
Okay, and again, thanks for coming. We'll meet again tomorrow. If you have any questions, we'll be here for another 20-30 minutes. So feel free to complete all your queries and get completed with all the progress that we've done so far before coming for tomorrow's session. Okay.
Guys, if you have any doubts, join down. We'll be there to help you out.
I'm gonna start